The human eye has two lenses that work together to focus light onto the retina. The outer focusing lens is called the cornea. The inner focusing lens is called the crystalline lens. Light rays pass first through the cornea and then through the crystalline lens and are focused onto the retina. From the retina, these light rays are sent as electrical pulses to the brain, where our mind sees a picture of what's in front of us. The natural crystalline lens of the eye is made mostly of water and protein. For most of us, sometime in our 60s, 70s, or 80s, some of this protein will clump together, causing the natural lens inside the eye to become discolored and clouded. This clouding of the natural lens is called a cataract and is usually a natural part of aging, but can also be hereditary or caused by disease or injury. When the natural lens gets clouded, light rays become scattered and no longer pass clearly through to the retina. At first, this cloudiness may affect only a small part of the lens, but over time, the cataract usually becomes larger, darker, and harder and has a greater effect on vision. As cataracts develop, all objects, whether near or far, become blurred, and vision usually worsens. One of the results of developing a cataract is the loss of ability to see in low-light situations or at nighttime. Other signs of a cataract include hazy or blurred vision, colors that seem faded or not as bright as they once were, sensitivity to light, and frequent changes in eyeglass prescription. To remove the cataract, your surgeon will use a technique called phacoemulsification, or phaco for short. The phaco procedure begins with a self-sealing microscopic incision that allows the surgeon to insert a tiny probe. Next, the thin front surface of the capsular bag that contains the crystalline lens is opened to provide access to the cataract. Your surgeon then uses the probe to gently break up the cataract and vacuum it out in tiny pieces, making way for the placement of the Tecnis intraocular lens implant. The Tecnis foldable lens is then inserted through the microscopic incision and into the lens capsule where your natural crystalline lens was previously located. Following the procedure, the Tecnis lens implant may provide safer, sharper vision, more like your own natural lens did when you were a young adult. Tecnis is the first and only intraocular lens implant, or IOL, approved by the United States Food and Drug Administration to improve functional vision and reduce spherical aberration, which may provide a meaningful safety benefit for older drivers. The Tecnis IOL was developed using an advanced optical measuring system called wavefront technology. With wavefront technology, optical scientists and eye physicians were able to scan the cornea and natural crystalline lens of a representative sample of the population. Based on these advanced wavefront measurements, optical engineers created the patented Tecnis IOL with a modified prolate lens surface that allows the Tecnis lens implant to function more like the natural lens found in a healthy young adult's eye, instead of functioning like the natural lens typically found in a healthy older person's eye. The result is a lens implant that helps provide clear, sharp vision in all light conditions. Our eyes, like other parts of our body, actually fall out of balance with age. This means that the outer focusing lens of the eye, the cornea, and the inner focusing lens of the eye, the crystalline lens, no longer work as well together. The result is vision that is not as clear and crisp as it was in our 20s, and cataracts only make the problem worse. In the eye of a healthy young person in their 20s, The cornea and the crystalline lens are in balance and work well together. The cornea has what scientists call positive spherical aberration, and the crystalline lens has what is called negative spherical aberration. The result of this balance is that light rays, as they pass through the cornea and the crystalline lens, are properly focused onto the retina. This provides clear, crisp vision in low light and bright light conditions for most people. As we age, the spherical aberration of the crystalline lens begins to change. The result of this change is that the cornea and lens, which worked well together when we were young, become out of balance. When these two focusing lenses get out of balance, the light rays entering the eye no longer focus as sharply on the retina, and the clear, crisp vision we had in our 20s is not quite as sharp. In medical terms, this is called a loss of functional vision. In practical terms, it's called not seeing as well as we used to, and it's especially noticeable to most people in low light or nighttime conditions. The result is that many older people quit driving at night or reduce other low-light activities. Traditional IOLs have been used to treat cataracts for the past 30 years. While replacing the cataract with a traditional lens implant greatly improves vision, it still leaves the cornea and lens somewhat unbalanced, like that of a healthy older person, instead of vision like a healthy younger person. Vision with a traditional IOL is better, but not as good as it could be for many people with the Tecnis lens. The Tecnis intraocular lens implant is designed to restore the balance that existed between the eye's cornea and crystalline lens, more like that of a person in their 20s. Through the use of wavefront technology, the Tecnis lens is designed to restore the balance between the cornea and lens, so that light rays are once again focused sharply and crisply on the retina, and functional vision is significantly improved. As we age, and as the eye's two focusing lenses are no longer in balance, the result is a loss of functional vision. In practical terms, this means that our vision is not as clear, and objects in lower light conditions, such as a gray truck or a child in a light jacket at dusk, are no longer easy to see. Recent clinical studies have shown that a loss of functional vision when driving in low light conditions can make it more difficult to detect objects and road markings. This is where the benefits of Tecnis technology are most apparent. A U.S.-based clinical study showed improved contrast sensitivity with the Tecnis lens in low-light conditions. While the improvement was not statistically significant in that study, other studies have shown a statistically significant improvement in contrast sensitivity. One study, for example, showed that the Tecnis lens may provide an improvement in contrast sensitivity up to 31% in bright light conditions, and up to 53% in low light conditions compared to a traditional spherical lens. In the following simulated driving scene, notice how difficult it is to see road signs or other cars when contrast sensitivity is reduced. In the daytime, many people with a traditional lens implant see like this. But with the Tecnis lens, contrast sensitivity may be improved up to 31% in bright light conditions, making images clearer and more recognizable. At nighttime, the difference between vision with a traditional lens implant and Tecnis can be even more dramatic. Contrast sensitivity with the Tecnis lens may actually be improved by up to 53% in low light conditions when compared to a traditional lens implant. In the 1980s, researchers showed that the addition of a third rear brake light provided an additional 0.35 seconds of braking time for drivers. As a result, it was required by law for all new automobiles in the United States, Europe, and in many other countries. According to a Potomac Institute study, the addition of these third brake lights has had both a safety and economic impact, preventing tens of thousands of injuries and saving hundreds of millions of dollars in property damage each year. In a simulated night driving study, the Technis IOL was shown to provide 0.5 seconds of additional reaction time. That's an extra half second to apply the brakes on your car after you recognize an object. This half-second increase in perception and reaction time is functionally significant in increasing your ability to take evasive action, stop, or lessen the effect of an impact. This is 43% more additional braking time than was provided by the addition of a third rear automobile brake light. So what is the value of this extra half second of reaction time in terms of stopping distance? The night driving study demonstrated an improved identification distance of 45 feet at 55 miles per hour, showing that improved functional vision can improve driving safety. Let's look at the following example of what is gained in stopping ability with the Technis lens compared to a traditional IOL. In this simulated driving scene, we see a car at dusk pulling out from a side street. With a traditional lens implant, it can be difficult to detect objects, such as another car on the road, when lighting is not ideal. This can significantly increase the risk of an accident. But with the Technis lens, notice the improvement in functional vision. When objects on the road are recognized and identified sooner, a driver can stop sooner, up to 45 feet at 55 miles per hour. This can create a meaningful safety benefit for older drivers and for the drivers and pedestrians with whom they share the road. Most of us are familiar with the term 20/20, but what does that mean? When we get an eye exam, we look at an eye chart on the wall called a Snellen chart, with black letters on a white background in ideal lighting conditions. If we have 20/20 vision, that simply means that under ideal conditions in a doctor's office, we see at 20 feet what a normal person with good vision sees at 20 feet. The eye chart, however, does not always represent how we see in real life in different light conditions. Look at the same eye chart in low light. With a traditional lens implant, contrast sensitivity is reduced. Notice that the person still has 20/20 vision, but they do not see the chart nearly as well as they could with the Technis lens. A U.S.-based clinical study showed improved contrast sensitivity with the Technis lens in low-light conditions. While the improvement was not statistically significant in that study, other studies have shown a statistically significant improvement in contrast sensitivity. One study, for example, showed that the Technis lens may provide an improvement in contrast sensitivity up to 31% in bright light conditions and up to 53% in low light conditions compared to a traditional spherical lens. Notice that the same eye chart in low light conditions is much sharper and clearer. This improvement in vision under real-world conditions is called functional vision. In simple terms, the Technis IOL can improve how well we see and therefore how well we function in a range of light conditions.